student, welcome to my channel. This is Mensuration part 5 of class 9, the last part of this chapter, which I have not made. I had moved till quadrilaterals only, triangles and quadrilaterals. This is the last part, circles. Okay. See, this is a circle. Okay. This is the center. Let the center be O. Now, if you take any point on the circumference P and join OP, okay, join OP. This is called radius. Okay, I had told this in the chapter circles, geometry. Okay, and this is the boundary of the circle. Okay, the length of the boundary is called circumference. That means if you start from point P, if you go on measuring the length of this boundary, okay, and end at P. So start from P and end at P. The length of the boundary is called circumference. Okay.
Yeah.
So formula for circumference is circumference means length of the boundary, okay, or perimeter, is equal to 2 pi r. Pi is a constant, it is an irrational number, it is a constant whose approximate value is 22/7. It is not exact. The approximate value is 22/7. Okay, which is almost equal to 3.142. Okay, it is a non-terminating and non-recurring decimal. Okay, it will continue. I don't know the other values. It is a non-terminating and non-recurring decimal, so it is an irrational number. Its value is approximately 22/7 or 3.142. It is a constant. R is the radius of the circle. So this is the formula for circumference. Next we have area, which is pi r square. Okay, so these are the two formulas, circumference and area. Now let us go for semicircle. This is a semicircle. Okay, let the center be O. Now its area is obviously half. Full area is pi r square. Half area will be half pi r square. Okay, then perimeter. Now see the perimeter. This part, the total will be 2 pi r, so half will be 2 pi r by 2. 2 pi r by 2. Then this is the diameter, this is r, this is also r. So its length is 2r. Okay, so 2 cancel, pi r plus 2r. So if we take r common, pi plus 2. So this is the formula for perimeter of a semicircle. Okay. Now let us go to examples. Move to exercise 20C. Move to exercise 20C. Question number question number 2. Okay. The circumference is given 308 meter and we have to find the radius first, which is given 2 pi r is equal to 308 meter. Okay. We have to find the radius. So 2 into 22 by 7 into r is 308. So r is equal to 308 into 7 by 44. 2 into 22 is 44. Let us simplify. 11 4 are 44. 11 2 28 4 7. So 49 meter. Okay. So radius of the circular field is 49 meter. Now let us go for area. Area is equal to pi r square. 22 by 7 into r is 49. 49 into 49, which is 7546. Okay, so this is the area occupied by the circular field, 7546 square meters. Okay. Now let us move to question number 8. Question number 8. A circle of largest area is cut from a rectangular piece of cardboard with dimensions. Okay. Suppose this is a rectangular cardboard. Okay. Dimensions are 55 cm. Cm. 55 cm and 42 cm. We have to cut a circle out of this cardboard of largest area. Okay. So the circle must be touching the sides of the rectangle like this. Okay. So its diameter must be 42 cm. This is also 42 cm. Okay. So we got the diameter, means we will get the radius. Then we have to find the ratio between the area of circle. So let us find area of the circle first. This is question number 8. Area of circle is equal to pi r square 22 by 7. Diameter is 42. Radius will be 21. Okay, 21 into 21. So answer should be 22 into 1386. So this is the area of the circle that is cut out of this rectangular cardboard. Now let us find. The question is find the ratio between the area of the circle cut and the area of the remaining cardboard. Okay, so remaining cardboard means this part. Okay, this part. So let us find its area. Area of remaining part is equal to, how to find the area of the remaining part? Area of the rectangle minus area of the circle. Area of the rectangle is length into breadth. So 55 into 42 minus area of the circle is 1386. Okay, which is which is 55 into 42 is 2310. 2310 minus 1386, which is equal to 1386, 924. 924 square cm. Okay, so area of the circle is 1386 square cm and area of the circle means the remaining part is 924 square cm. And now we are going to find the ratio between these two. So required ratio is equal to 1386 by 924. So let us simplify this. Okay, so this is 308,462. Then 11 to the 22, 28, 42. 7 4 7 6 the required ratio is 3:2. Okay, the required ratio is 3:2. This is the answer. Now move to question number 11. Okay, move to question number 11. The diameters of three circles are in the ratio 3:5:6. Okay, so d1 is to d2 is to d3 is equal to 3:5:6. Okay, d1 means 2. We are not interested in diameter, so I want to get radius. 2r1 into 2r2 into 2r3 is 3:5:6. Okay, r1 is 2, r2 is 2. Remember, if the same number is with each term of a ratio, this is a ratio having three terms, 2r1, 2r2, 2r3. Okay, so a ratio can have two terms, can have three terms, can have four terms, it can have any number of terms. But if there is something common, just like here, see 2, 2, 2, then you can neglect it. Okay, you can neglect it. So r1 is to r2 is to r3 is 3:5:6. There will be no change in the value of the ratio. So the same ratio 3:5:6. So let r1 is equal to 3x, r2 is equal to 5x, r3 is equal to 6x. Okay. Now sum of the circumferences is 308. That means 2 pi r1, 2 pi r2, 2 pi r3 is 308 given. 2 pi r1 plus r2 plus r3 is 308. 2 into 22 by 7 into. Now what is r1 plus r2 plus r3? r1 is 3x, r2 5x, r3 6x. If you add all these three, R1 plus R2 plus R3 is 3x plus 5x plus 6x, which is 14x. Okay, 14x is 308. 7 into 2 is 14. Okay, so x is equal to 308 by 2 into 32 into 2. Okay, so this is 2 into 2, 4, 4, 7 is 28, 4, 7 is 28. 11 to 11, 7. So x is equal to 7 by 2. Okay, x is equal to 7 by 2. X is equal to 7 by 2. So now we have to find the difference between the area of the largest and the smallest of these circles. Okay, so the largest circle has radius. The largest circle has radius 6x, which is 6 into 7 by 2, which is 21 cm. The smallest circle has radius 3x. 3x. Okay, so 3 into 7 by 2 is 21 by 2 cm. 3 into 7 by 2 is 21 by 2 cm. Okay, so these are the radii of the biggest and the smallest circle. Okay, we have to find the difference between their area. Okay, so let us find. Difference in area is equal to pi r square minus pi r square. Pi common, r square minus r square. Okay, which is equal to pi is 22 by 7. Okay, r square means 21 square. R square means 21 square, which is 441. Then small r square means 21 by 2 whole square, which is 441 by 4. 22 by 7 into 4. Okay, 22 by 7 into 3, 2, 3, 1. 1, 3, 2, 3 by 4. So let us simplify this. 7 1 is 7. 7 is 56. 7 is 63. 2, 11. So 180, 11 into 189 by 2, which is 9, 1, 0, 2079 by 2, which is 1039.5%. Okay, so this is the difference between the two circles. The largest and the smaller circle is 1039.5 square cm. Now move to question number 13, 1, 3. Okay. Question number 1, 3, 13. The circumference of a given circular park is 55 meter. There is a circular park like this. Okay, its circumference is 55 meter it is surrounded by a path of uniform width 3.5 meter. Okay, means there is one more circle outside it. There is one more circle outside it, and the width is 3.5 meter. Okay, the width is, this width is 3.5 meter, and the circumference of the inner circle is, means the circular park is 55 meters. Okay, we have to find the area of the park. This is the park. This is the park. We have to find its area. Okay. Now such a figure is called annulus. Remember this. There are two circles. There are two circles having the same center. These are called concentric circles. Okay. Circles having the same center. Ready? And this shaded region is called annulus. Annulus of the two circles are said to be concentric because they have the same center, and the region bounded by the two circles. Okay, the region bounded in between the two circles, that is the shaded region, is called annulus or circular ring. Now, how to find its area? See. Area of annulus is equal to area of the outer circle minus area of the inner circle. Okay. So pi common r square minus r square. So pi, this can be factorized. Okay. So this is the formula to find the area of an annulus or circular ring. Pi whole into r plus r into r minus r, and this r minus r is width. Remember this. This r minus r is called width. Pi value we have 22/7, but we don't have r. Simply we have r minus r. But we don't have r plus r. Individually we don't have r and r. Capital R and small r we don't have. We have to find. Okay, so let us find. And remember this formula. This is for annulus. Okay. So let us go for the inner circle. Circumference is 55 meter. 2 into 22/7 into r is 55. R is equal to 55 into 7 by 2 into 22. Okay. So 11 2 are 22. 11 5 is 55. 35 by 4 meter. This is the radius of the inner circle. Okay. Now let us go for capital R. Now capital R is equal to C. This is small r. This is small r, which is 35 by 4 meter. Just now we have found. And this value, the width of the path is 3.5 meter. So the capital R will be small r plus width. Okay. Small r plus width. So r is equal to small r is 35 by 4 and width is 3.5. 3.5 means 7 by 2. Okay, 3.5 means 7 by 2. On taking LCM, 35 plus 14, which is 49 by 4 meter. So now we have small r and capital R. We can easily find the area of the path or annulus. Okay. So let us go for it. area of path is equal to pi r plus r into r minus r, or you can use r square minus r square, whichever you are comfortable with. Okay, I am comfortable with r plus r or r minus r. I am using this one. You can use r square minus r square, which is 22 by 7 into, now r plus r means this plus this. Okay, this plus this. So 49 by 4 plus 35 by 4. Then into r minus r is width of the path, which we have already got 3.5 or 7 by 2. Okay, so 22 by 7 into 84 by 4 into 7 by 2. Okay, so let us simplify. 7 cancel. 2 into 11 is 22. 4 2 is 4 1 is 4. So 11 into 21, which is 231, which is 231 square meter. So area of the path surrounding the circular path having width 3.5 meter is 231 square meter. This is the area. Okay. Now move to question number 15. Question number 15. Okay. Wheel problem. A wheel has diameter, number 15. A wheel has diameter 84 cm. D is equal to 84 cm. R is equal to 42 cm. R is equal to 42 cm. Find how many complete revolutions must it make to cover a distance of 3.168 km. Okay, so distance is equal to 3.168 kilometers. Okay. Now see, radius of the wheel is given in cm and distance is given in kilometer. So you have to make the unit same. You have to maintain uniformity. Okay. Either change this to kilometer, which will be a big decimal value. Okay, or change this to cm. It will be better to convert to cm. Now 3.168 km is equal to into 1000 meter. So 3168 meter. Now let us change it to cm into 100. 31600 cm. Okay. Now how to find the number of revolutions? See, when a wheel, makes one complete revolution. Okay, suppose this is a wheel, and it is moving along this line. Okay, it is moving along this line. When it makes one complete revolution, suppose after making one complete revolution, the wheel has moved to here. Okay, the wheel has moved to this position after making one complete revolution. Okay. Now this is point A and this is point B. Okay, this is point A and this is point B. Now what is the distance between A and B? Okay, in terms of the radius of the circle. Now see, this distance AB is equal to the circumference of the circle, which is 2 pi r. Remember this, the distance travelled by a wheel in one complete revolution is equal to its circumference, which is 2 pi r. Okay, so one revolution pi r. Okay, that's n revolutions. Suppose it is making n revolutions, then the distance traveled will be 2 pi rn. Remember this formula. So the distance traveled by a wheel in n complete revolutions is 2 pi rn. Remember this formula, we will use this here. So 2 pi rn is equal to distance 2 into 22 by 7, radius is 42, and we don't know, we have to find distance is 316800 cm. Okay, so 7 into 6 is 42, m is 316800 by 2 into 22 into 6. Do not multiply because we are going to divide. Okay, now let us divide. 11 into 2 is 22, 11 into 2 is 22, 96, 8, 800. 2 into 2 is 4. At a time I am dividing by 4. So 4 728, 4 to 0, 0. Now 7200 by 6, 6 to 8 is 72. So 1200 revolutions. Okay. So the wheel has to make 1200 revolutions in order to cover a distance of 3.168 kilometers. Okay. Now move to question number 17. Move to question number 17 related to this. Okay, wheel problem. Question number 17. An express train is running between two stations with a uniform speed if the diameter of each wheel of the radius of each wheel of the train is 42 cm. So diameter is 42 cm, radius is 21 cm, and each wheel makes 1200 revolutions per minute. Okay, so n is equal to 1200 revolutions per minute. Okay, now see, in this question we have been asked to find the speed of the train. Okay, speed of an object is usually given in meter per second or kilometer per hour. Meter per second or kilometer per hour. So let us go for second, meter per second. That will be easier. Once we get the speed in meter per second, we can easily convert to kilometer per hour. Okay, by multiplying by 18 by 5. So that is not a big deal. Let us go for meter per second first. Here the number of revolutions is given in per minute. So let us convert to per second. Okay. So how many revolutions does it make in 1 second? In 1 minute 1200 revolutions. In 1 second 1200 by 60 per second, which is 20 revolutions per second. Now this is very important. The number of revolutions per second is very important because it is going to give us the speed. Okay. Now distance covered in 1 second. Okay, distance covered by the train or by the wheel of, by each wheel of the train in 1 second is equal to 2 pi r by formula 2 into pi into r into n. Where n is the, here n is very important. Here n is the number of revolutions made by each wheel in 1 second, because I have taken 1 second. The distance covered by the train in 1 second is equal to 2 pi r n, where n is the number of revolutions of each wheel in 1 second. If I write a distance covered in 5 minutes, okay, distance suppose 1 minute, sorry, distance covered in 1 minute is equal to again 2 pi r. But at that time n will be number of revolutions per minute, that is 1200. Similarly, distance, if we want to find distance covered in 10 minutes, then we have to take n, which is number of revolution in 10 minutes. Okay, here 1 second, so 1 second. So we are going to take this one, 20 revolution per second. 2 into 22 by 7, radius is 21, and number of revolution in 1 second is 20, which we have already found. So 7 into 3, now this is 44 into 60, 2640 cm. Okay, 2640 cm. If we want to convert it to meter, then this will be 26.4 meter, because by 100. If you want to convert cm to meter, then you have to divide by 100. So 2640 cm is equal to 26.4 meters. So this is the distance traveled by the train in 1 second, which is nothing but speed. What is speed? Speed of an object is the distance traveled by the object in unit time or in 1 second. Okay? When we take into consideration time along with distance, we get speed. Simply distance is okay, distance, but distance in a specific time is speed. The distance in specific time 1 second is nothing but speed. So this is the speed of the train. So speed is equal to, we can write, speed is equal to 26.4 meter per second. So this is the speed of the train. We have not been asked to give the speed in kilometer per hour. Had we been asked to give the speed in kilometer per hour, then we could have multiplied 26.4 means 264 by 10. 26.4 means 264 by 10 into, if I want to convert to kilometer per hour, then 18 by 5, right? Which is equal to, this is equal to 264 into 18 divided by 50, 95.04 kilometers per hour. So in this way, if the number of revolutions of each wheel of a train or car or truck is given and diameter or radius of the wheel is given, then you can easily find the speed of the object. Okay, either in meter per second or in kilometer per hour, whichever is asked in the question. Now move to question number 25. Move to the last question, 25. Okay, last question 25. The question is, a metal wire, question number 25. A metal wire, when bent in the form of an equilateral triangle of largest area, encloses an area of 484 root 3 square cm. Okay. Now area of an equilateral triangle is root 3 by 4 a square. This I had given in triangles. Triangles means mensuration part 1 and 2. Okay, I had given triangles, formula for isosceles triangle, scalene triangle, Heron's formula, equilateral triangle, etc. Okay, right triangle also. So this is the formula for equilateral triangle. Root 3 by 4 a square is equal to area. Now what is the area? It is given 484 root 3 square cm. Okay, square cm. So a square is equal to 484 root 3 into 4 by root 3. Okay, so root 3 cancel. Do not multiply. We are going to find square root. So a is equal to 484 into 4 is square root. Square root of 484 is 22. Square root of 4 is 2. So 44 cm. 44 cm. So each side of the equilateral triangle is 44 cm. And you might remember in wire problem, I had solved one or two wire problems in the previous parts of this chapter only. I told that the length of the wire is very important. Okay, once you get the length of the wire, you can get everything, because it will be the perimeter for every figure formed from that wire. Now it is equilateral triangle, so its perimeter will be 3a. 3 into side, so 3 into 44 is 132 cm. And this is nothing but length of the wire. Okay, this is nothing but length of the wire, 132 cm. Now what we are going to do, the same wire, now it will be expanded. Expanded means it will be opened. It was closed to form an equilateral triangle. Now it is opened. It becomes straight now. Then again it will be bent to form a circle of largest area. Okay. So the wire will look like this. Okay. The wire will be bent in this form to form a circle. Now what is its area? Now how to find the area? We need radius. Now how to get radius? We can get the area from radius, and we can get radius from the circumference. And what is circumference? The length of the wire. The length of the wire is not going to change. Means perimeter of the figures will not change. So circumference means 2 pi r is 132 cm, which is not going to change. If you form a rectangle, square, parallelogram, trapezium, anything you can make with this wire, the perimeter is not going to change. It will remain 132. So 2 into 22 by 7 into r is 132. So r is equal to 132 into 7 by 2 into 22. 11 2 are 22. 11 1 are 11. 11 2 are 22. 4 3. 21 cm. So radius of the circle is 21 cm. Then we can easily find the area. Area is equal to pi r square 22 by 7, radius is 21, so 21 into 21, 7 into 3, so this will become 66 into 21, which is 1386. 1386 square cm. So this is the area of the largest circle that can be formed using the same wire. Now you can see, first it was an equilateral triangle. Its area was 484 root 3 square cm. Now 484 root 3 means 484 root 3 means 838.31 square feet. Now the same wire was in the shape of an equilateral triangle, the biggest equilateral triangle possible, and this area was 838.31 square feet. The same wire is converted, is formed or bent in the form of a circle. Now its area is 1386 square feet. But the perimeter doesn't change. In case of equilateral triangle or in case of circle, the perimeter remains the same, that is 132 cm. So remember, for wire problems, area may change. Area will definitely change. Okay, but perimeter will never change. Okay. Now see whose area is more, equilateral triangle or circle? Definitely the circle. Remember, using a wire, you can form different types of figure. You can form triangles, quadrilaterals, pentagon, circle, anything. You can make ellipse. Okay. The largest area will be occupied by circle only. Remember this. So if for a given circumference, or given length of wire, you want to form a figure having the largest area, then you have to form a circle. Circle has the largest area having the same perimeter. Okay. So I hope you have understood this part. Okay. So thank you for watching.